Good morning, everyone. Thank you for joining us today and welcome to Production Modeling Corporation's web presentation. Today's topic is Immersive Assembly Planning, VR-enabled assembly planning with Tecnomatix Process Simulate. Our presenter today is Kaur Tosi. He is a digital manufacturing engineer at PMC. Please note that your microphones have been muted to prevent any background noise throughout the presentation, as it is being recorded. If you have any questions throughout the presentation, please utilize the Q&A button at the bottom of your screen. We will be holding a live Q&A session at the end of the presentation, and that's where your questions will be answered. If you have any issues with sound or visual errors, you also utilize the Q&A as well, and I'll do my best to help you as the presentation moves forward. As I mentioned before, the webinar is being recorded, so if you miss anything, don't worry, as it'll be uploaded to our YouTube channel at a later date. Now, before we get started, I'd like to do a brief introduction to PMC. Since 1979, PMC has helped over 700 companies by completing more than 7,000 performance-enhancing initiatives worldwide. It is our commitment to excellence that has brought us to the point where we are the largest independent industrial engineering services firm here in North America. PMC has worked with hundreds of businesses across all industries to improve their business's performance, and shown here at the bottom of your screen are just a few of our current and repeat customers. Next slide, please. Today's session will focus around simulation and process simulate, but here's a few of our other work areas that we do. These include things like quality and operational excellence, laser scanning and CAD, dynamic and static simulation, and traditional IE work. Now, I'd like to introduce Kaur Tosi, begin our presentation on immersive assembly planning. Kaur, take it away.
Hello, everyone. So now I'd like to introduce myself to begin our presentation. So my name is Kaur. I'm a digital manufacturing engineer implementing digital factory projects, mainly focused on robotic cell simulation, ergonomic simulation, and also discrete event simulation through PLM platforms, especially with Siemens Tecnomatix platform. I have 10 years experience in this digital world, and the vast majority of my projects were aimed at the automotive industry. So that's the agenda for today's webinar. So we'll start with an introduction to simulation. We'll have an overview of Process Simulate software. We'll cover the key features of Process Simulate, Process Simulate Human. We'll focus on virtual reality part and some peripherals like head-mounted display. I will show the setup of the HTC Vive equipment. We'll go into virtual reality functionality within Process Simulate. We'll check its benefits. We'll enter in details in the live hands feature, Vive body tracking, virtual reality sequencer in Process Simulate. We'll have the conclusion, and finally, we'll go into the Q&A section. So let's start by talking a little bit about simulation. Now, what is a simulation? So simulation is the use of a computer program to model a real-world system and its key behavior in order to validate decisions that affected the system. So through the simulation, we can create and we can compare multiple scenarios to make informed decisions considering all the possible angles. So this enables our client to try out different ways of operating the system without experiment with the real system. So here I have below here some examples of simulation. So we have traffic simulation, robotic simulation, for example, discrete event simulation, and also human simulation or ergonomic simulation. So here we'll talk a little bit about Process Simulate software. So Process Simulate software is a software developed by Siemens as a part of Tecnomatix platform. And Tecnomatix is a suite of digital manufacturing tools designed to help companies optimize manufacturing process and overall production efficiency. So Process is a digital manufacturing solution that allows us to build, test, optimize, and validate a 3D manufacturing environment, and to perform simulations of industrial robots and humans in their workplace. And it allows organizations to virtually validate manufacturing concepts in advance. So, in other words, we spend more time in the planning phase with the simulation so that when installing a new production line or changing an existing process, no problems arise. So here I have listed some key features as process simulation. So it helps in analyzing and optimizing the efficiency of this process before they are implemented in the real world. We have robotic simulation, so we are able to simulate the movements of industrial robots and ensure that they can perform these tasks accurately and efficiently within a given production environment. We have human simulation, so we are able to analyze ergonomics, worker safety, and overall human-machine collaboration, for example. We also have plant layout optimization, so it helps in minimizing bottlenecks, reducing cycle times, and improving the overall flow of materials and products through your facility, for example. We have offline programming in Process Simulate. So it means that we can generate and we can validate robot programs in a virtual environment before deploying them to the actual robots on the shop floor. Digital twin integration. So digital twin is a virtual representation of a physical system or product. So it allows for real-time monitoring, for example, analysis and optimization. And we have collaborative engineering. So it allows multiple users, engineers to work on a project simultaneously. So this can enhance communication and coordination among different teams that are involved in the manufacturing process. Okay. So within Siemens Process Simulation, Siemens Process Simulator software, we have a dedicated tab to simulate the operator at the workstation. This is the Process Simulate Human. So we can plan their operation and process into this virtual environment. We can model and we can size the virtual human in the simulation, and we are able to design manual workstations within a 3D visual environment to evaluate the ergonomics of the workstations to ensure the safety and well-being of the operator. So we can evaluate, for example, injury risk, operator reachability, line of sight, energy expenditure, and fatigue. So we have a realistic human motion and performance simulation. And at the end of a simulation, considering the human, we can also export a simulation report. And what's virtual reality? So here we have an overview. Virtual reality refers to a computer-generated simulation of an environment or experience that can be interacted within a seemingly real or physical way. And this virtual environment would typically be created by a combination of computing hardware and software. And this includes headsets, sensors, controllers, and other devices. And the goal of virtual reality is to create an immersive experience that that tricks the sense into feeling as if they are in into a fantastical environment. So it can be used in a variety of fields, including entertainment. For example, it's widely used for gaming, for example, because it provides a highly immersive and interactive gaming experience. But we can also use for education, for example. It can offer simulated experiences for educational purposes. So, for example, students can explore historical sites or practice some medical procedures or engaging in realistic training simulations. We can also use it into healthcare, for example, for therapy, rehabilitation, for example. It can help patients to overcome phobias or manage pain and maybe improve motor skills, for example. We can use it for training purpose, for example. So as an examples, we have aviation, military. They can use virtual reality for training simulations because we have a controlled environment where we can practice a series of scenarios. And we can also use it for architecture and design. So it can enable architects and designers to create virtual walkthroughs of the buildings and the space before they are constructed. So VR is typically created by a combination of hardware and software. So we have the headsets. So these are devices worn on the head that immerse the user in a virtual environment. So they often include screens or lenses that display this content, the virtual world, and may also incorporate some sensors to track the head movements for a more immersive experience. It depends on the manufacturer. We have input devices. So these are tools that enable users to interact with the virtual environment. For example, controllers or gloves, or even full body suits equipped with sensors to capture the human movements. Computer hardware, for example, because virtual reality typically requires powerful computing devices to generate, to render these complex graphics and simulations in real time. And finally, we have software. So virtual reality applications and experiences are created using some specialized softwares. And this can range from video games and simulations to educational programs and virtual tours, for example. So here you can see these are components of a virtual reality system. In this particular case, we have a HTC Vive model. This was the first to be compatible with Process Simulate software. Okay. So in A, we have base stations. In B, we have the controllers. In C, this is our HTC headset. Here on the right, we have an image of how the space is configured. So in D, we have the interface box. The interface box connects the headset with the computer, basically. In E, we have the computer that is compatible with virtual reality. And in F, we have the tracked workspace. This is the basically this is the available space to enter the virtual environment. This is the available space to experience the virtual reality. So going a little deeper into the details of the HMD, the head-mounted display, which is our virtual reality headset, in which has a small optical display in front of HI and display the digital content into this wearable headset. So it consists of a display unit. We have lenses, we have sensors, depending on the model. So sometimes we have audio devices integrated into a single device that can be worn on the head. So here we have several purposes. So we have it for gaming, as I commented, aviation, because we can have some pilot training, for example. We can use it to military for simulated missions, for example. We can have it in manufacturing for equipment operation or training operator. We'll see that in the next slides. or for medicine, for example, for some medical procedures. These are some examples. Okay, so here we have some recommended specifications of a computer to run the HTC Vive equipment. This is specific for the HTC Vive. So for processor, we have Intel Core A5-4590 or AMD FX 8350 or a better one. Graphics NVIDIA GeForce GTX 1060 or AMD Radeon RX 480 or a better one. Memory at least 4 GB RAM. Video output, one HDMI port, display port or newer one. USB 2.0 port or newer one, 3.0 for example. Operating system, Windows 7, 8.1, 10, or also 11. And to run the HTC Vive, we must have the Steam software installed on the machine. So, as I commented, the Steam is the software for the HTC Vive. This is one of the only ways to allow the computer to recognize the HTC Vive headset. So this is a software, it's very known as a gaming platform, as a gaming software, but in the recent years, it has become a go-to service for anything virtual reality. So it's necessary to install the base stations to track the headset and the controllers before starting the Steam software setup. So when you plug in the HTC Vive, the Steam VR software setup will automatically start up. So here I show you how the link box is connected to the headset and the computer. It's quite simple. The link box is used to connect the headset to the computer. So we have 3 cables connect to the link box on the computer side, and we have 3 cables connect to the link box for the headset side. So in the first image on the left, we have the 3 cables on the computer side, which would be the USB. This is what we have here is L1 cable. We have the display port, L2. And on L3, we have the power cable that goes into the socket. In the middle image, we have the cables on the computer side and the headset side connected to the link box. And the image on the right, the last image, we have in the details the cable that connects the computer. We have the display port and USB. So here we have the base stations, and we have how to install them. So they must be mounted diagonally from each other and above head height. So higher than 6 feet and 6 inches tall, for example. We need to mount the base stations in the chosen position. And we need to plug in the base stations and set each channel. So, for example, if you are using the wired synchronization cable, we can use it to increase reliability, to connect the 2 base stations. Then one base should be channel A and the other should be channel B. If you are not using this wired synchronization cable, then one base should be channel B and the other should be channel C. So this is particular to the HTC Vive equipment, okay? Here's the Steam VR setup. So we're entering in the details. I'll show how the setup is made. So here we enter the room setup. So the first option that comes up is whether the user would like to set up for room scale or standing room. So room scale allows for the user to walk around in a selected space, while stand only is used if there isn't much area to use virtual reality, or if the user would like to sit. So the controllers will need to be turned on and placed with the headset in an area that can be seen by both tracking stations to establish tracking. Once the controllers can be seen by both base stations, The next step is to grab a controller, stand in the middle of the play area, and point the controller at the computer monitor while holding down the trigger on the back. So we can see it will progress here, this area. And then we can go to next. So the next step is I could say that this is the easiest step of all. So just locating the floor by placing both controllers on the ground and selecting the calibrate floor option in the SteamVR. And then this is the final step. This is is to measure the space of the area being used while in virtual reality. So the SteamVR software allows the user to use a controller to walk around the play area, and the software will track the path and create a real-time image of what has been tracked. I can say here, one potential issue is not mapping out enough play area. So the software will give an error to go back and remeasure until we have an appropriate amount of space created to use the virtual reality. Okay, so the setup is complete. So the HTC Vive is ready to be used for a process simulate application, in our case, or whatever application the user wishes. And now, anytime that the HTC Vive is disconnected or the computer is turned off, the SteamVR will remember and will retain all the information from the initial setup process. So for most applications, we can say that it's just a plug and play to enter the virtual world. And once the virtual reality equipment setup is complete, we can access the virtual reality functionality in Process Simulate. So in this environment, we immerse product and manufacturing engineers in their designs, and they can visualize the manufacturing process, assemblies within a 3D virtual environment. So we can see here in this video, we have some basic features. So we have a laser pointer, markup. We can play the simulation. We can reset, we can pause. We can use the flashlight. We have teleport. Right now we are just emphasizing some objects, the clamps, our fixture. We can put some notes. For example, imagine that we detected a simulation, for example, and we need to send this to other involved in the project, so other engineers, analysts. So we can just put some marking, take some screenshot, and send it to other involved in this project. So here we can see these are the basic commands, we can say, in Process Simulate for virtual reality. So we can access all these commands through the controller, through the Vive controller. So we have the laser pointer. It means that we can point to some object. We have the markup. So as I just commented, we can mark some objects. So for example, we detect a collision, so we can circulate it, for example, or put some drawing and send it to other involved in the project. We have object manipulation. So we can, for example, imagine that we have lots of robots in the scene. We can reposition one of them for a quick layout planning, for example, or some what if evaluation during the engineering's review, for example. We can play, pause and reset simulation anytime. We have flashlight command. So we can see dark areas like underbody areas, for example. We have teleport. So it allows to walk around. So it supports elevation change. For example, we can jump to the roof or going down below 0 level. It's not here, but we can also access through the controller the measurements. So we can take measurements from one point to another. So these are basic functionalities in virtual reality in Process Simulate. And what are the benefits of virtual reality in Process Simulate? So here I have listed some of the benefits of VR in Process Sim. So we have user interaction. So the users can navigate and explore the simulated manufacturing process in a virtual environment, so it can provide a more realistic, a more intuitive understanding of the layout and the operations, for example. We have collaboration. So the teams, engineers can collaborate in a virtual environment to review and discuss the manufacturing process design. So it makes it easier to identify potential issues and to make some improvements. And we can use it as immersive training. So the virtual reality can be utilized for training purposes. So users, it allows users to simulate and practice some tasks in a virtual space before executing them in the real manufacturing environment. Well, I showed you the basic features of virtual reality in Process Simulate. And here we have a feature that Siemens added in one of its software updates, which is the live hands feature. So it basically allows you to select and interact with certain objects while immersed in the virtual reality environment. So right now you have an interaction with the objects. You can take apart and assemble it into a product, for example. And this also allows the ergonomist or the simulation expert to envision hands scale and bolster it from Process Simulate posture library. So with this, you can carry out hand clearance studies, improves hand clearance studies, and validate simulations moving objects in an assembly sequence. And another feature that Siemens added in a following update was the Vive body tracking feature, which would be a low-cost alternative for capturing the body movements and modeling complex postures in the simulation environment. And with this alternative, we eliminate the third-party motion capture system, because we can use the existing HTC Vive trackers. We already have the headset, and we have the hand controllers with the Process Simulate tracking algorithms. So with this capability, we use 6 HTC Vive trackers that are, as we can see in the image, these are attached to the human body at the C7 vertebra, pelvis, both elbows and both feet. We have 2 HTC Vive controllers, and we have the HMD, the head mount display. And it's also possible to record the movements made by the avatar using a feature called a posture record. We can pause and we can resume tracking, and we can review all the movements while immersed into the 3D environment. So here we have other pictures. So the tracked person can pick, can place and manipulate objects with the live hands feature active. So we can say that this offers a first-hand experience with interacting with parts and workstations design proposals, and allows you to outdoor movements that include the whole body as the part objects. So this also allows for accurate studies of reachability, clearance, and strength. And after the Vive body tracking functionality, another feature was added. So this is the virtual reality sequencer, as you can see in the video. So this is a combination of the live hands feature with the Vive body tracking feature. And it allows you to compile a sequence of tasks in the Process Simulate. So it can be run in virtual reality for a guided experience, for example. So when you run the defined sequence in virtual reality, it will appear as a tablet in the scene, showing the instructions that you must follow. For example, instructions for assembling a certain product. It's a feature that can be used when we introduce new products into the line, for example, or for planning, validating assemblies, for example, troubleshooting purposes, for example, and also for training operators before introducing them to the shop floor. So here in this video, you can see that the person enters the avatar body and begins training on assembling. We have a scooter. So we'll start the training. We have the instructions here. So we can see some arrows, and these arrows indicate which parts to pick up, or whether to pick them up, and whether they should be placed, for example. So we have the blue arrow indicates where to pick, and we have the green arrow that indicates where to put this part. Okay, so after creating the 3D environment, everything is programmed within the simulation using this functionality. Okay, and then it's complete. So when activating the virtual reality sequencer mode, it will appear a blue circle on the ground that indicates where to start the assembly sequence. You can program that. You can choose the place to start the training. So we have some arrows indicating the steps to be followed and which objects are to be moved from where to where as programmed in the virtual reality sequencer. So here we have some images. So when entering this blue portal, we start the virtual reality sequencer. So we receive this welcome message, and then we must move the hand with the controller to click on the start button, and then the blue arrows will appear, and it will indicate where the objects that must be picked up are in the model, and the green arrows indicate where this object must be placed. And whenever a step is completed, we can see the tablet updates and shows the next step to be taken. So you must follow the instructions for all these steps. And when we finish, the tablet will show the time it took you to complete this whole assembly. And all this movement carried out to assemble a product can be recorded, as I commented, through the posture record functionality. So this is converted into an operation within the simulation. So you can run, after that, you can run this human operation without being inside the virtual reality environment. Because if necessary, you can also make some adjustments to this operation. For example, if the arm movement wasn't very good, for example, you can make these fine adjustments directly to the operation you recorded. That's an example. So you can see in this video, the human's movement is captured and passed to the avatar through the trackers. He's using the virtual reality sequencer to carry out this training on assembling we have here the body of a motorcycle. So in this case, just to finish the training, the simulation is recorded. So as you can see, he's performing the movements are being recorded through the trackers and the record feature. And then we can, if necessary, we can adjust that. We finish the operation. It will appear in our operation 3 in Process Simulate. We can adjust that anytime. We can play this operation anytime. And here you can see the time it took to complete that. And then this is the operation. The operation is saved directly in the simulation. And if necessary, we can adjust fingers movement, arms, or other adjustments. And here, at the final of the training, we can also see this. We can access this ergonomic report. So it also shows whether his positioning was good or bad, and in which part of the process. So just to conclude today's webinar, we can say that the Process Simulate integrated with the virtual reality, it becomes a very powerful tool for training new operators or introducing new products and new process within a controlled environment without compromising the real environment. So here at PMC, we have a team. We have a highly qualified simulation experts, engineers who can guide you in robotic or human simulation projects and integration with virtual reality. So you can visit our website anytime for more information. And this was our webinar today. So we covered the concepts of simulation. We did an overview of Process Simulate software, key features, Process Simulate human. We understood a little about how the virtual reality works in Process Simulate. What is the HMD, the head-mounted display, how to configure the HTC Vive, the first one that was compatible with Process Simulate, virtual reality in Process Simulate, its benefits, some details of the live hands feature, Vive body tracking feature, virtual reality sequencer, and the conclusion. So just to conclude the webinar, I'm going to hand it back over to Brian so we can get into our Q&A section.
Yep, thank you, Cora. We did have a few questions coming throughout the presentation, and we'll get started with those. But please, if you have any questions specifically for Cora about the presentation, I recommend you use the Q&A feature to have Cora address those for you. So with that, Cora, the first question that we did have come in is there any other headset that can be used in Process Simulate besides the HTC Vive?
Yes, the HTC Vive was the first virtual reality headset to be compatible with Process Simulate. But as Process Simulate releases new updates, we have other headsets that have become compatible. So we have HTC Vive Focus 3, which is a standalone virtual reality headset that operates wirelessly, and it eliminates the need for the base stations. We also have another one. It's the HP Reverb G2 headset and controllers. This one was developed in collaboration with Valve and Microsoft. And taking the opportunity to talk about these controllers, Process Simulate right now is also compatible with the Valve Index controllers that feature the sensors to detect some basic finger posture. So it adds even more realism to this immersive experience. But yeah, you can experience greater hardware flexibility, and you can select the best virtual reality hardware depending on your needs.
All right, thank you, Cora. The next question we had, could PMC provide virtual reality support to help train new workers on a construction or mining or quarrying site to operate heavy equipment safely?
Right. PMC can help you in doing that as consulting or as a project. We can create this environment in Process Simulate, for example. This is the feature that we are using right now for this kind of training. We can model your completely scenario and program the virtual reality training Process Simulate. Yeah.
All right, thank you, Cora. The next question we had, are there any safety concerns associated with VR training?
Yes, and I can say that it may include risk of motion sickness, for example. Another important thing, we can have some potential discomfort from wearing these virtual reality headsets for long periods, for example. And I can say that we need to ensure also a safe physical environment during the immersive experience without objects, for example, and an empty space for the immersive experience. That's really important.
All right, thank you, Cora. The next question we had, what are the challenges associated with implementing VR training programs in Process Simulate?
Well, the challenges can include, for example, the initial cost of the virtual reality equipment, for example. We also have costs associated to the Process Simulate software. It's very expensive because inside Process Simulate, we also have a lot of modules. For example, Process Simulate Robotics is one module, Process Simulate Human is another module, welding feature is another module, continuous feature is another module. So it's very expensive. We have the Process Simulate software costs. I can say that we can have some technical issues. So we need specialized content creator, I can say, engineers or experts capable of creating the scenarios, and not only create but program this training in VR using the Process Simulate. And another thing that is regarding challenges, we can say that we have a ongoing need for updates and maintenance. So it's also good to have a really good IT support team to deal with updates and new versions of softwares and install them. That's another good point to mention.
All right, thank you, Cora. I don't see any further questions coming into the chat box, so I will close the Q&A. So thank you for answering those questions. For a schedule of upcoming topics related to PMC, please be sure to visit our website at www.pmcorp.com. From there, click on the Resources tab and scroll down to Webinars and Events to register for future PMC presentations. As I mentioned before, this webinar is being recorded, so please be sure to visit our YouTube channel, search PMC videos, that's videos with an S and all one word, to view other potential topics of interest to you and your team. But that will conclude today's webinar. I'd like to thank everyone for your participation. If you think of any additional questions or like to discuss how PMC can help you design and implement your own process improvement strategies, please contact us at the address now on your screen. We look forward to working with you or perhaps joining you at another one of PMC's productivity improvement web seminars. Thank you and have a great day.